Alrighty, friends, this is chapter 12. This one's kind of a doozy. I don't know why, but this is always challenging for students. So we're going to dive into this together, and you have a sheet that has all the formulas on it, so it's really important that you look at what it's asking and then find the formula that matches. Here it says, what type of sequence are each of the following? Keep in mind that arithmetic means you're adding or subtracting a common difference. Geometric essentially means you're multiplying by some ratio or maybe dividing by a number, and neither means you're not doing either. So if you look at this, if you kind of just look at the pattern, you can see that you are multiplying these by 2, making it geometric. Here, this is kind of tricky. I can see a pattern here where I'm adding 2 to the top and I'm adding 3 to the bottom, but you can't, like, you can find the pattern separately, but I'm not adding the same fraction and I'm not multiplying by the same fraction to get to the next thing. The top and the bottom have separate patterns. So this is going to be a neither. And then here, it looks like I am adding 4 each time. So that's going to make this arithmetic because I'm adding. Here we're supposed to find the first 4 terms. So if I'm looking at, like, what do you want me to do? Find the first 4 terms. This is an explicit formula, and that's going to mean plugging in 1, 2, 3, and 4. So to find the first one, I'm going to do 2 times 1, and then 1 minus 2. So that's going to turn into a negative 2. So the first thing I need is a negative 2. Unfortunately, they all have a negative 2. So we try plugging in the second. So I'm putting in a 2 now anywhere there is a number that actually gives me a 0. So I need something that goes to 0. So these 2 are out. My third number, I'm plugging in a 3 for n. Excuse me, and you would use your calculator for this. And that turns out to be a 6. So I need the third number to be a 6. So that means I'm on C, because I needed to have first a negative 2, then a 0, then a 6. And because I already was wrong in the third spot, I can narrow it down through elimination to C. Doing the same thing here. First 4 terms, I got to plug in 1 to get the first term. So I need something that starts with 3, so C is out. Second term is going to be 3 times 2, which is 6. So this is out, this is out. A must be my answer. Use the fact that this is a multiple choice test to your advantage. Now I have to write the rule. This is a little bit tricky, but it tells me it's arithmetic. And if you look on your chart, there's a box that says arithmetic explicit. And it shows A sub n equals A1 plus D n minus 1. So I'm going to go ahead and put in those pieces. I know the first term is 12, and I can look and see that my common difference is going down by 2. So I'll have minus 2 and then n minus 1. And then we distribute and combine. So I'm going to distribute that negative 2, keeping in mind that when you do negative 2 times negative 1, it becomes positive. And so I ultimately end up with negative 2n plus 14 because these two are alike and can go together. So I'm looking for negative 2n plus 14. So my answer is C. But you got to read the problem to figure out which thing you should be looking for. So for example, explicit rule, arithmetic, same as up here. So I'm supposed to plug in my first number, which I can see with my eyeballs. And here I can see that my common difference is plus 4. And I know it has a common difference because it tells me it's arithmetic. So plus 4 n minus 1. And then every time I do the same thing. Distribute and then combine the numbers. So 4n minus 11. So I'm looking for, again, it looks like letter C. Here I'm finding the sum. If you're finding the sum of the first 15, you need a sum formula, and it tells you it's arithmetic. So go look at your formulas. You need the sum of arithmetic, and it looks like this. First term plus last term. Now, sometimes you have to go back to this formula when you don't know everything. They're telling you that 15 is the number of terms you're adding up. So that goes here and here. That's why n is the same here and here in the formula. I need the first number in the list, which is 9. And then I need the 15th number. So I need A sub 15, but I don't know it because it just goes on. So to find out the 15th number, I'm going to use this other formula and say, I know the first number, I know the common difference is 2, and I'm going to go 15 minus 1, because if you look up here in the formula, this is an n, and this is n minus 1. So since I have a sub 15, I'm going to have 15 minus 1 in there. So when I do that problem, I end up with a last term of 37. And then I type this whole shenanigans into my calculator and I end up with 345. That would be the sum of all of those numbers if I added up the first 15. So that is going to be choice B. Same thing here. It says find the sum of the first 15 in the arithmetic. So I'm using the exact same formula. 15, I'm going to have 15 over 2 again. I need the first number. And then I need to find the last number. But to find the 15th number, I use the other formula, which is start with the first number and then add the common difference, which here it's going up by 4. So I'll add 4 and then 15 minus 1 times again. So I'm doing the exact same process that I did up above. When I do that on my calculator, this turns into 36, meaning the 15th number in this row, if I kept going, would be 36. Then I put all of this into my calculator, and when I do, I get 120. And so my answer is D for number 21. Here I'm evaluating a sigma, which is going to be a sum. And if you look at this, this is geometric because that's the style of this. You have a number in front of your ratio and then to the n minus 1 power. That's your geometric if you look on your formula sheet. So this means sum. And so I'm going to be adding up 5 numbers because it says to start with 1 and go to 5. So 1, 2, 3, 4, 5 means I'm getting 5 terms that I'll be adding together. When I look at my geometric sum formula, it looks like this. On my card, A1, 1 minus the ratio to the nth power, 1 minus the ratio. So in this case, I have to find the first term by plugging in this bottom number for the n. 1 minus 1 is 0. Anything to the 0 power is 1. So my first term is actually 6. This is your common ratio inside the parentheses. So I'm going to have 1 minus and then my common ratio to the power that matches n and then over 1 minus 2/3. Now these are tricky to get into your calculator correctly. So I always recommend that you do just this top part first. And then once you get that, you can divide by the bottom part and use parentheses so it knows that whole thing is the bottom. And then multiply by that 6. So if you do that, grab your calculator, you're going to go 1, subtract, parentheses 2/3, raised to the 5th, and you get like 0.868. Then divide by, in parentheses, 1 minus 2 over 3. Now I have 0.5209. And then I multiply that by 6, and I'm getting like 3.1259, blah, blah, blah. But I'm going to have to change that into a fraction. That's something we've had to do a lot this year. So make sure you know how to do that on your calculator. And I'm getting this, which matches none of these. I'm looking at her answer key too. She has the wrong thing in her calculator. So this is the right answer, but I don't see it here. I don't think that reduces either. So anyway, it's closest to this, but that would have to have a 135 on the bottom. All right, well, that was weird. So here we go. We're going to try it again. Okay, here's my R, and then I need to do 4 terms this time. So I'm adding up 4 terms. I need my first term, putting in a 1 for n. 1 minus 1 is 0 again. 2 to the 0 power is 1. 1 times 2 is 2. And then 1 minus my ratio to the power that matches how many terms I'm adding over 1 minus the ratio. So I'm going to grab my calculator, 1 minus 2 to the 4th power, and get that answer, which is negative 15. I'm going to divide by, and then in parentheses, so it knows that that whole thing is on the bottom. That's just going to turn it into positive 15 times 2 on the outside, and I'm ending up with 30 as my answer. So that one, what number am I on? 23. So 30 is option B. Okay. Sum of infinite. So look on your card. That's what I'm saying. Like, figure out what they're asking you and then match it. You have a formula that says this. A1 over 1 minus R, but the absolute value of your ratio, or common ratio, has to be less than 1, meaning you have to be multiplying by something less than 1. To find your ratio, you can take any of the numbers and divide by the number in front of it. So if I went to my calculator and did negative 3 over 2 and then divided that by negative 2, my common ratio here is 3/4 or 0.75, which is indeed less than 1. And so I am going to be able to use my formula. So my formula says to put in the first term, which is negative 2, and then on the bottom, do 1 minus your R, which is 1.75. Remember these parentheses, they're super important to getting the right answer. So if I do that, I'm going to take negative 2 divided by, and then in parentheses, 1 minus 0.75, and I end up with negative 8, which is C. So this is all about finding the right formula. So again, sum of infinite geometric series. I go to my card. This is my formula again. And then here, though, when I go to find my ratio, I can take any number and divide by the number in front of it. I'm getting negative 2. The absolute value of negative 2 is not less than 1, so it's too big. So this one does not exist because the ratio has to be less than 1. The numbers have to be getting smaller, and these numbers are not getting smaller. And so I can't add them up. So I end up with like doesn't exist or infinity kind of answer. All right, here we are. Explicit rule, geometric. So I go to my card. Explicit rule says use the first term, then the ratio to the n minus 1 power. So I need the first term. That's 22. I need the common ratio. I can either figure it out or take any number and divide by the number in front of it. And I'm going to find out that it's negative 1/2. And then it's just matching. So 26 turns out to be C. So you got to just give in and be like, explicit rule for geometric, find that on my card. Here we go. Explicit rule, geometric, find that on my card. And on my card, that is still going to be this. So I still need the first term, which is 8. And then I figure out what I'm multiplying by. I can do that by taking any number and dividing the 1 by the 1 in front of it, and it'll tell me my ratio is 3, and then to the n minus 1 power. And I don't care if the 3 is bigger than 1. I'm not trying to add them up. So now I just match. Not sure why it says 3 over 1. That's a little bit weird, but 27 is D. I mean, essentially 3 over 1 is still 3, but it just looks weird. Given recursive rule. Okay, recursive is where you get 2 lines. One line tells you where to start. So this is your first term. And then the second line tells you what to do. So start with 8. So I can only have options that start with 8. And this says to get any term, because this always means take the number before. To get any term, take the number before it and multiply it by 0.5. So basically you're taking half. So if I did half of 8, I'd be at 4. Half of 4, I'd be at 2, and so on. So that is matching B. Same thing, recursive. This tells me the first number is a 7, so all of them have that. This is saying take the number before that and subtract 2. So to fill this blank, I take the number before that and subtract 2 and fill it with a 5. So this is out, this is out, this is out, this is the only in. 29 is going to have to be A. That is the end of chapter 12. It's 100% about using those formulas. So read the words and then use the formula that it just describes. Bye.